Day3 doing LeetCode. This problem is subarray product less than k. Okay. So given an array of integer nums and an integer k, return the number of contiguous subarrays where the product of all the elements in the subarray is strictly less than k. Okay. Okay, so need to return number of contiguous subarrays. So let's say in this case, okay, the element in the element in the array is larger than 1, smaller than 1000. That means for the production, the more for the product of the subarray, the more element there is, the more the larger the subarray product is. So what I think about would be, I think about using a sliding window, and whenever I will, for the window, I will just use the right and left pointer to bound the window inclusively, and when I move the right pointer to right, whenever I see a new element, I will make product. And while I do this, I always try to compare whether it's less than k. If it's not less than k, that means I need to shrink until it is less than k. And if it's impossible in this case, okay, that means I'm not going to increment. So that's what I'm gonna do for this one. Okay, I'll try to code the solution to see whether it works. So let's have the result, which is number of contiguous subarray where the product of all elements in the subarray is strictly less than k. We got result equal to 0. We got left pointer equals to 0. It goes through nums. We have the current product. Let's call it 1. So we have the current product becomes nums right. So, well, the current product is smaller than k. That means that we need to remove the left one. So by remove the left one, we got current equals to current product divided by nums left. After that, we always increment left. And after all this, we check so how do we check whether this is a valid one? After we divide everything here, we wanted to see whether it is current valid so that we can increment the result accordingly. In this case, let me think. So I will definitely make sure that since this is a contiguous subarray, I assume this is a non-empty contiguous subarray. So we wanted to make sure in the while loop, not only the current product should be smaller than k, but also the right minus left plus 1 should be larger than 0. Should be larger than 0. If after this move it no longer holds, let me think whether this is happening. We can use example 1 when nums is 1, 2, 3 and k is 0. So you got 1 here, and after we add this, we found the current product is smaller than k. So we try to divide the current product by 1. If we found okay, we deleted, but currently the left pointer is larger than the right pointer. This is not going to work. And our approach is that we do not want this to happen. So let me think whether I have already checked this. Let me think. So the current product is smaller than k. We wanted to just keep divide, but in the 1, 2, 3 example, k equals 0 example, we cannot just keep a k forwarding, so we need to add a restriction for this. Okay, after adding this restriction, we are strictly making sure that left pointer is not going to exit the right pointer. But after all those processes, how we make sure that it's a valid subarray and we should increment. We need to make sure here, after this, there's something more to check. So here I wanted to make sure that after all these checks, so after going through the while loop, we can just make sure that the current product is not, the current product could be should be just larger or equal to k, or it is larger or equal to k. So let me think whether this, after this process, whether this will just work. I think it will not work as you need to consider the case when k is 0. So we just check whether the current product is it is possible that the current product is smaller than k, but it's just exit the loop. We can go through the example enums equal 1, 2, 3, k equals 0 here. Current product is, okay, we go through this. Well, current product becomes 1, 1 is smaller than 0. I mean 1 is larger or equal to 0. And currently the length is still larger than 0. No, it's not. It's not. This is not gonna work. It's not gonna work. So the current product, and it will only work when it's still larger or equal to 0 because it's inclusive. One element is still fine. Okay, and the current product is just equal to current product divide. I don't think it can divide the left one, because if an element divide its left, it's just removing itself from here. And we don't want to shrink. We don't want to shrink when we don't want to shrink if there's only one element. So this is what we need to handle. After the while loop, because this will even not going to enter it. It will not even enter it, right? And after this case, if it once it enters, the left pointer will be larger than the right pointer, and this is not what we expect. But we expect this in the next iteration, right? So what I'm gonna do after this, if it is already larger or equal to 0 and it has length, okay, we will just update the current product equals to it, just to decrease itself, and this becomes 1. But how about, I think this doesn't work. this will not work because if k is 1 and if k is 1 and this gives 1, this is not going to work. Or if k is 2 and this is not real. If k is 2 and 3 should be k is 4. I am thinking about what is a good way to just make sure that the current product, okay, let me think, the current product is larger or equal to k, and the right, and the length of the window is larger than 0. Length of the window is larger than 0. What am I featuring in this while loop? So I am not so sure about this part. Let me think. If the current product is larger or equal to k, that means we wanted to shrink the left to see whether it works. But we cannot keep shrinking until it exists. I think we need to handle the case when there is only one variable. If there's only one variable, this is a case that will help you do everything. If there is only one variable, if there is larger than one variable, but for things that has larger than one variable, we still need to make sure that the current product is okay. This while loop only works for the ones that has larger than 0. How about it just shrinks to, because we need to find all the possible ones. How are we going to do with it? Once we found something there, we are going to increment. I think this part we just should increment. We also wanted to make sure anything less than that, the combination of everything less than that will also work as well. So how am I going to deal with that? Because this is the longest one that works. This is the longest one that works. And all the ones smaller than this should work as well. How can I do this? I think this is quite a math problem. I don't know. I need to find all the combinations. All the combination numbers is in this case. For example, we found current one, we have a length of 5, and anything less than that till 1 should work as well. So how am I going to do this? All the combinations, because this is how to do that. If I have a 5-element subarray that works well as the largest or the longest product, and I think the ones for 4, for 3, for 2, for 1 should work as well. How am I going to include that? And yeah, that's it. I don't know how to do this right now. I need to check. I'll ask how to continue to find the combination. So let's stop here. I'll use another video to do this.